Hello and welcome. We ended last lecture being able to log in with the user that we created during Spring Boot startup. This is great. However, there is a problem. While creating a user, we store the password in clear text. This is something to be avoided at all times. Never ever store sensitive data in clear text, especially if this data is about your customers. Not to worry, in this lecture we will address this issue. We will introduce Spring BCrypt password encoder, modify the user service so that it encrypts the password before delegating to the repository layer the task to store the user record in the database. And finally, we will integrate the BCrypt password encoder with Spring Security. First, we'll make sure we are pointing at the develop branch with the git command git checkout develop. Then, we will create a new feature branch with the git commands git checkout -b BCrypt, git push -u origin BCrypt. There are various ways to encrypt sensitive data. We can use one-way encryption or two-way encryption. One-way encryption only allows to encrypt data before, say, persisting it. Two-way encryption allows also to generate the original value from the encrypted value. For our website, we will use a Spring BCrypt password encoder bean. This bean offers one-way strong hashing using the BCrypt hashing algorithm. Adding encryption to our website with BCrypt is quite simple. First, we will declare a string constant that we will call salt. A salt is a sequence of random characters that can be used in conjunction with encryption to give encryption a personal signature. Go ahead and hit a few keys at random on your keyboard to define the salt value. It's important though that once defined, you never change it. Also, if you are thinking of eventually using the DevOps Buddy website for your own business, it's important that the salt is not shared with anyone. In a commercial business, this would probably be stored in a database. Then, in the security config class, we declare a bean of type BCrypt password encoder and name it password encoder. The full constructor accepts a strength, which by default is 10, and the secure random instance. From the Spring Java doc documentation for this class, we know that the larger the strength, the more work will need to be done exponentially to hash the password. So it's a question of finding the balance between speed and strength. For example, I've tried with a strength of 20 and the application took more than 2 minutes to start up. The application was still noticeably slow with a value of 15, although it took only, so to speak, 10 seconds to boot. I found that on my machine, a value of 12 seems to strike a good balance. As the second argument, we will pass a new secure random instance, passing as argument a byte array generated from our salt string. Finally, in the configure global method, we invoke the password encoder method on the auth object and pass the bean that we have just declared as argument. Now we need to modify the user service so that he encrypts the user password before delegating to the repository the task of storing a new user record. We will auto-wire an instance of the BCrypt password encoder. Then, in the create user method, we will encode the user password and set it in the user entity. That's it! If we now restart the application and log in with basic user and secret, we will see the payload page. However, let's add to the H2 console by visiting localhost 8080/console. If we run a query on the user table and look for the password column, we will see that the password has been encrypted. Congratulations! Now you know how to encrypt sensitive data using a one-way hashing algorithm via the BCrypt password encoder, and how to integrate password encryption with Spring Security. The last thing we will need to do is to close the Git flow workflow. First, we will push the local changes remotely with the git commands git add *, git commit -m, added password encryption to Spring Security, and git push. Then we will merge the code to develop with the git commands git checkout develop, git merge BCrypt, and finally git push. Thank you for your time, and I see you in the next lecture.